All right, I'm going to talk about solving absolute value inequalities. Absolute values look like this. I have like, and what this means is it's greater than, the distance from 0 is greater than 2. So I have to figure out what the distance from 0 is. So I'm going to go x plus 1 is greater than 2 without the absolute value. I'm also going to go x plus 1 is less than 2. Less than negative 2. This is going to give me the distance away that is on the negative side. So if you think about it, here's 0, here's 2, here's negative 2. These are both the same distance away from 0, so I have to find both of those. That's what absolute value means. So subtract 1, x is less than negative 1, subtract 1, x is greater than 2. Something can't be less than negative 1 and greater than 2. Those are two separate things. On my number line, it's going to be, how is that 2? 1. It's going to be greater than 1. So it's an open circle at 1 and it's going this way. And it's going to be less than negative 1. So it's an open circle at negative 1 and it's going this way. So how do I represent that in interval notation? So on my interval, it's going to go from negative infinity to negative 1 or 1 to infinity. And that's what we're going to be looking at, okay? Whenever we do the negative 1, we switch the direction of the inequality. So when you have something like this, before you do anything else, you have to get the absolute value by itself. I'm going to make this 14 actually. You have to get the absolute value by itself. So I'm going to subtract 9. I'm going to get 2, absolute value x plus 3 is greater than or equal to 5. Divide by 2. Absolute value x plus 3 is greater than or equal to 5 over 2. Now I can set it into two separate ones like I did on the last one. So I'm going to go x plus 3 is greater than or equal to 5 over 2. X plus 3 is less than or equal to negative 5 over 2. Subtract the 3, which is really 6 over 2, so x is less than or equal to negative 11 over 2. Subtract the 3, again 6 over 2, x is greater than or equal to negative 1/2. So again, on the number line, these are going away from each other, so when I write it in interval notation, I'm going to say I go from negative infinity to negative 11 over 2. This time it's included. Or I go from negative 1/2 to infinity. And that's how I would do these guys. Okay. Now we have some special cases. If I get the absolute value is less than a negative, that cannot be done. It doesn't matter what this negative number is. That's never going to happen. The distance can never be negative. So when the absolute value is all by itself, if it's less than a negative, I'm going to have an empty set. If I get the absolute value by itself and it's greater than a negative number, doesn't matter what that number is, this distance is greater than a negative, no matter what I put in, it's going to be greater than a negative. So for this one, it's all real. Those are your two special cases. Now what I do to try to trick y'all is I'll put something like this. And you guys look at it and say, oh, it's greater than a negative, so it's all real numbers. But that's not true. The absolute value is not by itself. We're going to subtract the 9. I'm going to divide by negative 2. Remember, when you divide by a negative, the inequality has to turn around. So this is going to become less than or equal to 5. And now I go through the steps. So just because it started with a negative doesn't mean it's going to be absolute value in the negative, okay? So you got to get the absolute value by itself first.